Hello, Ms. Espinoza, and welcome to Mission PCR. My name is Purvi Balaji.
Sienna Curiel.
Ishan Nagpal.
And I'm Jack Doherty.
And in this video, we will be explaining the process of PCR through a mission. So, in the test tube, there need to be 5 core ingredients in order to proceed with the PCR process. There needs to be a buffer, so the conditions are right for the reaction, the DNA template that needs to be copied, which is the target DNA, and we have highlighted it with the green pipe cleaner here. Next, you need the primers, which initiate the PCR reaction. It binds to either side of the section DNA needing to be copied. So these are the primers, okay? And then the nucleotides, ACTG, which are used to build a new strand of DNA. And lastly, the Taq polymerase enzyme to add such glue in the new DNA bases.
Go.
The test tube from the previous clip, which has the buffer, target DNA, primers, nucleotides, and Taq polymerase, will be inserted into the thermocycler. Thermocycler raises and lowers the temperatures of the sample in a holding block and pre-programmed steps to allow denaturing and annealing of samples of reagents.
PCR is denaturing. This process starts with the 95 degrees Celsius heat, which heats the hydrogen bonds between the 2 strands of the target DNA, which cause the 2 strands to separate. These 2 single strands will act as templates for the making of the new strands of DNA. This process takes 15 to 30 seconds, and the temp of 95 degrees Celsius must be maintained.
The second stage is annealing. The reaction is cooled down to 60 degrees. This causes the primers to attach to the specific locations on the single-stranded DNA by hydrogen bonds. The primers are single strands of DNA or RNA sequences and are 20 to 30 bases long. The primers attach on the ends of the target DNA. Primers serve as the starting point for DNA synthesis. The primers must bond so that the Taq can start the new complementary strand from free DNA bases. There are 2 primers, from 5' to 3'. This takes about 10 to 30 seconds.
The last stage is the polymerization stage. The heat goes back up to 72 degrees to allow new DNA to be made by the Taq polymerase enzyme, which adds nitrogenous bases. The Taq polymerase is taken from heat-loving bacteria. The Taq polymerase attaches to the primer and binds the bases to the single strand. This results in a new strand of DNA and a double-stranded molecule of DNA. It takes about 1 minute to copy 1,000 DNA bases.
Go.
Multiple cycles of the PCR process happens. Cycle 3 equals 8 copies of target DNA. The cycle 4, as presented, equals 16 copies of the target DNA. The cycle usually ends at around cycle 25 to 30.
The final cycle, cycle 25, makes a total of 33 million copies of the double-stranded target DNA. This marks the end of the PCR process.